Good morning, students. Already we completed about that what is electrostatic and what is charge, and we have some properties of the charge, that is the quantization and the conservation of the charge and additive nature of the charge. Okay, so now we are entering to the new topic. Already we have some more brief explanation about the Coulomb's law. So Coulomb's law. Okay, so Coulomb's law, it mainly express the force of interaction between the two charges. Okay, so already in the 11th class, that is the first year, already we studied about the force of interaction between the two objects. Okay, so that is by the gravitational law. Okay, when we are considering the two mass objects, that is m1 and the m2, then we are having some force of interaction between those two, that is F is equals to some constant z into m1 m2 by r square. Okay, so that means the force which depends on the distance between the two objects and the masses of the objects, and here we are having some constant, that constant is gravitational constant. Okay, so this is in the already we studied about this one. So here this explained by the Newton. Now in the same way, so in electrostatics, okay, so Coulomb's explains the force of interaction between the two charges. Okay, so here there exists a mass for the charge also, but the charge is in the microscopic level, but here we are considering the masses which are in the macroscopic level. Okay, so in the microscopic level, Coulomb's explains the force of interaction between the two charges. Okay, so he considered that when we are taking the two charges, let us consider this is the one charge which is q1 and this is another charge q2. Okay, now here we are having some separation between those two charges, and he considered that the force of interaction between those two charges, that is F, must be proportional to the product of the two charges and inversely proportional to the square of the distance between those two. Okay, so here by comparing those two, he given the formula that F is proportional to q1 q2 by r square. Okay, so to remove this proportionality, here he consider one proportional constant, that constant is k, and that is q1 q2 by r square. Okay, so here this k value is constant, and this k value will be changes according to the media which is in between the two charges. Okay, so the media between those two charges may be air, or it may be any media, it may be water or any media. Okay, so that is depending on the media which affects the force in between those two charges. Okay, so will affect the value of the k. Okay, so here we want the value of k. So he given that the value of k is equals to that is equals to 1 by 4 pi. Here he have epsilon naught and the epsilon r. Okay, so that value must be is equals to 9 into 10 to the power of 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. Okay, so here what is epsilon naught and epsilon r? Okay, so this is the question here. Epsilon naught and epsilon r, which represents the permittivity. Epsilon naught is the permittivity of the free space, and epsilon r is the relative permittivity of the one. Okay, so here relative permittivity of the media, that is a, and we are having another one also, that is absolute electric permittivity. Okay, so if the media in between those two charges is air, okay, or the vacuum, then here we are considering the epsilon naught. Okay, so then ER will become 1. Okay, so if the media in between those two charges is the air or space, then here ER will become 1. Okay, so if we are having some another media in between those two charges, okay, so then we are having that ER may be greater than 1. ER will be greater than 1. Okay, so the relative permittivity of the space will be greater than 1 when we are having the another media in between the two charges. Okay, it will equals to the 1, it will be equals to the 1 when the permittivity of the when the two charges which are in the air media. Okay, so this is about the permittivity means here this is a charge which can express which can apply the force on this charge. So let us consider it will apply the force 100 Newton force on this charge. Okay, so if here is the air media, then it will allows the 100 Newton force that is applied on the second charge. Okay, if there is some another media, water or any media, then if it sends the 100 Newton effect of this charge, then only for 60 Newton force will be absorbed by this media. So that means it will not permitted 60 Newton force, it will only permitted 40 Newton force. So this 40 Newton force will be acted on this charge. Okay, so that means 60 Newton force will be absorbed by this media. Okay, so this is the permittivity means how much it is allowed, that is the permittivity. Okay, so here it allows only 40 Newton force, so this is the permittivity of this media. And if you are taking the another media, then that will allow 50 Newton force. That means that is depending on the media. Here we are getting some effect on the second charge due to the first charge. Okay, so this is about the permittivity of the space or permittivity of the media. Okay, so here we want to get the units for that epsilon naught and the epsilon. So permittivity of the next unit of epsilon naught. Okay, so for this here we are having F is equals to 1 by 4 pi epsilon naught and the epsilon r and q1 q2 by r square. Okay, so here epsilon naught and the epsilon r, when we are taking the air media, epsilon r become 1. Okay, so that is epsilon r is equals to 1 if we are considering the air media. Okay, so here we want the units for the epsilon naught, so that's why epsilon naught is equals to what? 1 by 4 pi f into q1 q2 by r square. Okay, so that is equals to epsilon naught is equals to q1 q2 means Coulomb square. Okay, so that is Coulomb square, and here r square means meter square. Here 4 pi is a constant and force means Newton. Okay, so that is equals to here by substituting the values. By substituting the values of the Coulomb and the by all this constant, here we are getting the value that is 8.85 into 10 power minus 12. This is the Coulomb square and per meter square per Newton. Okay, so this is the units, these are the units for the epsilon naught, and this is a constant value which is given for the epsilon naught 1. Okay, so now here we have to get dimensions for this epsilon naught also. So for dimensions of epsilon naught, here for the dimensions, here see here this is the 1 by 4 pi is constant and 1 by f. Okay, so that is 1 by f, and here q1 q2 by r square. No, so 1 by f means so this is a force, and q1 q2 by r square. If q1 is equals to q2, then let us consider q square by r square. Okay, so q square means Coulomb square. Okay, so that means already we know that I is equals to q by t. So q is equals to it. Okay, q is equals to it. So that means ampere into t. Okay, so here substitute here. So 1 by f means what? Okay, so 1 by f means what? 1 by f means m l t power minus 2, and q square means what? A into t kada. So a square t square and r square means meter square, so that is L square. Okay, L square. Okay, so t square, okay, so t power 4, so here we are getting per m and L power minus 3, t power 4 and a square. So this is the dimensions for epsilon naught. Okay, so here see here, so this is about the units of epsilon naught and the dimensions of epsilon naught. Okay, so now here okay, so here Coulomb find the force in between the two charges. So he used the torsion balance. Okay, so torsion balance he used to get the force in between the two charges. Okay, so and torsion balance means it is a sensitive device which used to measure the force. Okay, and Cavendish also to measure the large to measure the gravitational force. Okay, so he used this one, that is the torsion balance. Okay, so to verify the Newton's law of gravitation. Okay, now here we have to get some units for Coulomb, that is charge also already we known. So charge is the SI unit of the charge is Coulomb. The SI unit of the charge is Coulomb. And here in the CGS unit, this is the SI unit. If you are considering the CGS unit, in the CGS unit, so one electrostatic unit is equals to that of the one state charge, start charge. Okay, that is start Coulomb. Okay, so in the CGS method, here we are using the unit as the one start Coulomb, and in SI unit we are considering the 1 Coulomb. Okay, so this is about the units of the charge. Okay, and here we have to know that is somewhat about the dielectric constant, that is the relative electric permeability ER. Okay, okay, so dielectric constant, so that is the relative electric permeability ER. Okay, so relative electric permeability. So it also known to be a dielectric constant. Okay, so it is the relative permeability, it can be expressed as ER. So that epsilon R, okay, epsilon R, so that must be is equals to the force in the vacuum. So that is the force in the so here we are considering the two charges. If the two charges are placed in the vacuum space, then the force which exists in between those two charges will be the force is in the vacuum and the force in the medium. Okay, so if the force in the vacuum, it can be written as 1 by 4 pi epsilon naught and Q1 Q2 by R square. Okay, if we are considering the force in the media, then 1 by 4 pi epsilon naught and it will be epsilon R. Okay, so here we have to write the epsilon R also, and Q1 Q2 by R square. Q1 Q2 by R square, Q1 Q2 by R square cancel, epsilon naught 1 by epsilon naught, 1 by 4 pi epsilon naught cancel, and here we are getting what? Epsilon naught by epsilon. Okay, so this may be anything. Okay, so that is epsilon naught by epsilon. Okay, so here those two can be considered to be a epsilon. Okay, so that is relative permeability epsilon R is equals to epsilon naught by epsilon. Okay, so this is about the relative permeability. Okay, so here this is the relative permeability and this is the permittivity in the media and this is the permittivity in free space. Okay, so now and we have to get the Coulomb's law in vector form. Okay, okay, here we have in the medium law, so we have to write only epsilon. Okay, so now Coulomb's law in vector form. So here Coulomb is the some unit of the charge and the charge is a scalar quantity, so it has only magnitude. So that's why here we are expressed the force as the force in the force is equals to q1 q2 by force is proportional to q1 q2 by r square. That is only the magnitude. Okay, so here we have to get the Coulomb's law in vector form. Okay, so for the vector form, here we have the three coordinates. One is x and y and the z. So here it is the x and here it is the y, here it is the z. Okay, so now let us consider, here is the one charge. The charge may be q. Okay, it is that which is at some distance, that is r1 from the origin. So this is the origin point. Here we are having the q1 charge. Okay, so and here I am considering the another charge, that is the q2, which is r2. Okay, from the origin. Okay, so here this q1 is placed at the point A, here q2 is placed at the point B. Okay, so here r1 and r2 are the position vectors. Okay, so position vectors means the distance between the charge and the origin. Okay, so here we have to get another line joining these two charges, another line. Okay, so if q1 and the q2 are positive charges, then there exists repulsion force. Okay, if it is a positive, if it is a negative, so there is some attraction force. Okay, so here I am concerned that q1 and the q2, those two are positive charges, so there exists repulsion force. So that's why here q1 applies force on the q2, but here q2 moves in this direction, that is away from the q1. Why? Because as it is a positive charge, so it will repel the q2 charge. So that's why it will move in this direction. So here force acted on the charge 2 due to 1. Okay, now here q2 is there, so this q2 applies the force on the q1, this q2 applies the force on the q1, but as those two are positive charges, then q1 again moves away from the q2, because it is a positive, so there exists repulsion force between those two ones. So here q1 moves away from the q2. So this is the force direction, then force on the q1 charge due to q2. Okay, now here we are having that r1 and the r2 are the position vectors. Okay, and here F12 means this is force on q1 charge due to what? q2. Okay, so here force F21 means what? Force on second charge, q2 charge, due to first charge, that is the q1. Okay, now here q1 q2 are the two charges. Okay, now here this q1 applies the force on q2 and this q2 applies the force on q1, but here the force on q2 will moves in this will applies in this direction, and q2 applies the force on the q1 in this direction, and q1 applies the force q2 in this direction. Those two directions of the forces are in opposite direction, but the magnitude which applied by the two charges will be same. Okay, so that means here we have to prove force on first charge due to second charge will be equals to the force on second charge due to the first charge. That is, the magnitude is same, but both are in opposite direction. So here we have to get the negative charge. So first here we have to prove this one. Okay, now according to the Coulomb's law, already we learnt the magnitude of the force. Okay, so here this charge applies the force in this direction. So here we are getting some position vector. Okay, so that is the position vector is r, that is on the second charge due to first one. So that is the r2 one. Okay, so if this charge applies the force on this charge, then here we are getting the position vector r, that is force on the first charge due to the second charge. Okay, so that means here we are getting some resultant vector as a, that is a change in r. Okay, change in r as a resultant vector. Okay, so now here first we have to take this is a point A, this is a point B. Let us consider the charge Q1 applies the force on the Q2. So that means from A to B, from AB, here we are having the position vector is what? R12. Okay, R12. Okay, so that is the from 1 to 2. Sorry, here Q1 to Q2 is 1 2. This is in this direction, and R21 is this in this direction. Okay, so that is R12 is equals to, it can be written as R2 minus R1. Okay, so and the next one is from B to A, so that is R21, so it can be written as R1 minus R2. Okay, so now here this is the magnitude. Now here we have to get the force. So for the force, this is the resultant vector. So already we know that this and this can be added, these two added and gives the this second vector. Okay, so that means R1 plus R21, R1 plus, that is change in R must be is equals to the R2. Okay, so that means change in R is equals to R2 minus R1. Okay, so if this is in this direction, okay, so that means the force applied on the Q1 on the Q2, then it will be there. Okay, so if this will be in this direction, then those two are added and gives this one. Okay, so that means R2 plus delta R gives a R1. So that means R2 plus, this is from OAB, this is from OBA. Okay, so R2 plus delta R is equals to R1. So then delta R is equals to what? R1 minus R2. Okay, so delta R in this situation, delta R means what? R1 2. Okay, if we are going from here to here, then we are getting R2 1. Okay, so now here we have to get the force. Okay, so for the magnitude of force, okay, that is from Q1 to Q2, or that is force on Q2 due to Q1, Q2 due to Q1. Okay, so now here already we know that this is the unit vector. So unit vector is equals to what? R12 unit vector is equals to what? R12 vector by magnitude of R12. Okay, so this is the unit vector. Okay, so now here we want the force on the second charge due to the first one. Okay, so that is okay, so unit vector we can also written as R12 cap. So that must be is equals to, as unit vector is equals to 1, so if we are multiplied with the F12 vector, and it can be written as the magnitude of F12 or the F21. Okay, so that is F12 magnitude. So here we are applying the force on the second charge due to the first one. So F21, we have to take the F21. Okay, so here R12 cap means it is a unit vector. Already we know that the unit vector magnitude always is equals to 1. Okay, so that's why it can be written as R12 cap is equals to F21 by F21 magnitude, F21 vector by F21 magnitude. So it can be written as F21 vector is equals to R12 cap into magnitude of F21, magnitude of F21. Okay, so here according to the Coulomb's law, the magnitude of force is equals to what? 1 by 4 pi. If it is in the free space, we have to write the 1 by 4 pi epsilon naught. Okay, and Q1 Q2 by R square, Q1 Q2 by R square. Okay, so here it is from first charge to second charge, first charge to second charge. Okay, so if R12 is there, then it can be written as R12, the vector of R12 and magnitude of R12. Okay, so now write here R12 vector, that is by magnitude of the R12, and 1 by 4 pi epsilon naught, and Q1 Q2 by R12 square. r12 square. Okay, so now here this is the magnitude, this is also magnitude, and we can written as, so 1 by 4 pi epsilon naught q1 q2 by r12 whole cube into r12 vector. Okay, so this is the f21. Okay, now here r12 we can written as 1 by 4 pi epsilon naught q1 by q2. R12 means what? R2 minus R1 whole cube into R2 minus R1. So that is vector of R2 and vector of R1. Okay. So here we are getting the force on the second charge due to the first charge. Okay. So now in similar way, force on the first charge due to second charge can written as 1 by 4 pi epsilon naught q1 q2 by, here we are getting the r12, no, so here we have to write the r21 ante kada, the force on the second charge. Okay, so that is the force on the first charge due to the second charge, so that is r21. Okay, ఇక్కడ చూడండి, ఫస్ట్ ఈ ఛార్జ్ దీని మీద ఫోర్స్ అప్లై చేసినప్పుడు మనం ఈ డైరెక్షన్ తీసుకుంటాం కదా, అంటే r12 అంటే ఫస్ట్ ఛార్జ్ నుంచి సెకండ్ ఛార్జ్కి ఇది తీసుకున్నాం మనం, అవునా. ఇప్పుడు మనకి సెకండ్ ఛార్జ్ ఈ ఫస్ట్ ఛార్జ్ మీద ఫోర్స్ అప్లై చేస్తుంది, అది ఫోర్స్ అనేది ఈ డైరెక్షన్లో పోతుంది కదా. ఇప్పుడు ఈ సెకండ్ ఛార్జ్ ఫస్ట్ ఛార్జ్ మీద ఫోర్స్ అప్లై చేసినప్పుడు మనం ఎక్కడి నుంచి ఎక్కడికి వెళ్తున్నాం, సెకండ్ ఛార్జ్ నుంచి ఫస్ట్ ఛార్జ్ కదా, అంటే మనం ఏం రాయాలి, r21 రాయాలి, అవునా. సో హియర్ r21 whole cube into r21 వెక్టార్, అంతే కదా. సో ఇట్ కెన్ బి రిటన్ as 1 by 4 pi epsilon naught q1 q2 by r21 means what, r1 minus r2 whole cube into r21 means r1 minus r2. Okay, so this is the magnitude of f12. Okay, so by comparing, this is the first equation and this is the second equation. By comparing the equation 1 and 2, see here 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught same. So here q1 q2, but see here we are taking the r12 and here we are taking the r21. So this is r12 and this is r21. Okay, so that means the r12 is equals to minus of r21 అని రాయొచ్చు కదా. సో అంటే ఇక్కడ r21 మైనస్ r2 మైనస్ r1, ఇక్కడ r1 మైనస్ r2, మనకి ఇప్పుడు r2 మైనస్ r1ని r1 మైనస్ r2గా రాయాలంటే ఏం చేయాలి, మైనస్ కామన్ తీయాలి, అంతే కదా. సో అంటే f of force f12 must be is equals to minus of f21 అని రాయొచ్చు కదా. సో it is proved. Okay, so that means whenever we place the two charges, that is the two positive charges, so the first charge applies force on the second charge and second charge applies the force on the first charge. This charge applies the force on this charge will apply the force on this charge, but the force which is acted on those two charges magnitude will be same. Okay, so that is f12 is equals to f21, but the direction which is applied on those two charges will be opposite direction. The force will be in this direction and this force will be in this direction, both two are in opposite direction. This is the Coulomb's vector form, Coulomb's line vector form. Okay, Coulomb's line vector form.